So last week you were given the rules for a linear function and you had to graph them. And this week what's going to happen is you are going to be given situations, graphs, tables, and you're going to have to write the rule for each of those. So let's talk first about these like word problem examples over here. Sorry, I'm getting organized. There we go. Okay, so number 1, it says a school orchestra is buying music stands. The group has $298 in its treasury. Okay, that's just like your account or whatever. Okay, so they have $298. Each stand costs $42. Write a function rule to show how the balance in the treasury depends on the number of stands bought. Okay, so this last sentence is really important where it says the balance in the treasury depends on the number of music stands bought. So the way that we're going to write this is the balance is a function of the number of stands, right? The balance depends on how many stands we buy. And there we have $298, and then we're going to take away $42 for every stand. Okay, so this balance depends on the stands, and it's $298 minus $42 for every stand that we buy. So now it says use the function rule to find out what the balance would be if the school bought 5 stands. So we're going to fill that in. So we're saying the balance if we bought 5 stands would be $298 minus 42 times 5. Okay, so 42 times 5 is $210. So $298 minus, they just spent $210 on music stands, means that their balance would be, what is that, $88 left. Okay, so it's not that complicated, right? We've done these kind of things a bunch of times. It's probably just, figuring out, okay, well, which one depends on which, how do I write it, that sort of thing. Okay, so let's look at the next example, number 2. It says a rate for internet costs $15 a month plus 25 cents for each hour of use. Okay, believe it or not, you used to have to pay by the hour. And I think there's still like Wi-Fi cafes and stuff where you do that. Write a function rule to show how the monthly bill, okay, so the monthly bill depends on the number of hours used. So our bill depends on, it's a function of how many hours we use the internet. And we know that we have to pay $15 no matter what. And then we're paying 25 cents times every hour that we use the internet. So now it says use the function rule to find the bill for 80 hours of internet use. Okay, so what would be our bill if we used 80 hours? Well, we have to pay $15 no matter what. And then 25 cents times 80 hours, right? So 80 hours, so you can use a calculator, I just don't have one sitting right here, but $80 or 80 hours times 25 cents would be $20. So our bill is going to be $15 plus $20 for hourly use. So if we add that together, our total is $35. Okay, and then number 3. Says you charge $12 an hour for your babysitting services. Write a rule to show how the total you charge depends on how many hours you babysit. Okay, so the total you charge depends on how many hours you babysit. So your total depends on how many hours you babysit. Okay, and like on your homework and stuff, it doesn't matter to me whether it's like T of H or F of H or whatever. It doesn't really matter. But then this is just $12 times an hour. Okay, there's no like you have $50 to start or anything like that. So that's why we had this 15 and 298 because we had starting amounts. This is just $12 an hour. So it says use the function rule to find the total for 5 hours of babysitting. Okay, so if you babysat for 5 hours, it's just $12 times $5 an hour, which would be $60. Sorry, I have like a new little setup and I feel like it's shaky. Okay, so that's taking words and then writing a function rule for it. Now we're going to talk about what if you're given a table of values, how do you write a function rule for that? Okay, and I have written down here y equals, y is the same thing as f of x. Okay, so it doesn't matter whether it's a y or an f of x. But what's going to go in the first blank is change, gosh, this is so shaky, sorry, change in y over change in x. Okay, so essentially that's the same thing as the slope. It's the change in y over change in x. And what goes in the second blank is what y equals when x equals 0. Okay, so super, super important. In the first blank, and I don't know why I didn't actually write it in the first blank, that was kind of silly, is the change in y over the change in x, and then the second blank is what y equals when x equals 0. Okay, so let's look at it for this table. Okay, so y equals blank x plus blank every time. Okay, so what's our change in y? What's happening here? Is y going up 2 or down 2? It's going down 2 every time. And then what's our, right? It's going 8 minus 2, 6 minus 2, 4 minus 2. And then the change in x is going up 1, up 1, up 1. Okay, and it's weird because the tables can be written as x over y. They could be written vertically. Okay, but you just have to remember that it's the change in y over the change in x. So negative 2 over 1x, and then plus, what's y when x is 0? Well, when x is 0, y is 8. Okay, so we always want to write it in simplest form. So instead of negative 2 over 1, I'm just going to write that as negative 2x plus 8. Okay, and the cool thing is, you could plug these in and it fits. So like negative 2 times 0 plus 8 is 8. Negative 2 times 1 is negative 2, plus 8 is 6. Negative 2 times 2 is negative 4, plus 8 is 4. So these are all ordered pairs that came out of this equation. You're just figuring out the equation. Okay, so look at this next one. So it's the same, y equals blank x plus blank. And so to figure out what goes in the first blank, it's change in y over change in x. So what's happening to your y every time? If you're going from 8 to 5, that's down 3. 5 to 2 is down 3. 2 to negative 1, so it's going down 3. And then what's happening to our x? Negative 2 to negative 1 to 0 to 1. That's 1. Okay, and then when x is 0, what is y? 2. Okay, and again, we always want to write it in simplest form, so I'm just going to write it as y equals negative 3x plus 2. Okay, and that goes with this one, and this goes with this one. Okay, so look at this last one. Okay, let's look at what's our change in y. We're going up 2, up 2, up 3. What's different about this one? Okay, the change in y isn't constant, right? I added 2, added 2, added 3. So what that means is that this one is actually not linear. Okay, if I were to graph all of these ordered pairs, it would go, I would have the point like 0, 3, 1, 5, 2, 7, and then it would go 3, 10. So it's like not going to be a straight line. So we can't write a linear function for it because it's not linear. Okay, so if there's not a constant rate of change, right, we're adding 2, then adding 3, that means it's not linear. And on your homework, it'll just say like, is this linear, yes or no? And so just double check to make sure it's constant. Okay, so now turn your notes over or get out your second page. This is what it should look like. Okay, so it has y equals blank x plus blank. So think about what we just did, right? This was change in y over change in x. What's another name for change in y over change in x? The slope, right? And then what's another name for what y equals when x equals 0, right? So when x is 0, what's this y? When x is 0, what's that y? That's the exact same thing as the y-intercept. So like back on your last page, right? Change in y over change in x is your slope. And this point right here, 0, 8, that's the y-intercept. 0, 2, that's the y-intercept. So we're doing the same thing here, but we're just looking at our graph. Okay, so I'm going to do this one right here. So y equals, okay, if we're actually, let's just do it right here. Y equals, so if I'm looking at the slope, slope dude always moves left to right. So is he going from left to right? Is he going up and to the right or down and to the right? He's going down. So down 1, 2, 3 over positive 2. So down 3 over 2. So that goes in this blank, negative 3 over 2x. And then what's my y-intercept? It's crossing this y-axis at positive 2. So this would be my equation. Y equals negative 3 over 2x plus 2. Okay, let's do this one. So y equals, slope dude, pick a point on the left and go to the right. Is he going puff, puff, positive or nice, negative? This is nice, negative. And he's going down 1, 2, 3 over 1. Down 1, 2, 3 over 1. So I'm just going to write that as negative 3, right? I don't have to put negative 3 over 1. It's just negative 3. And then where is this crossing the y-axis? That is 0. So I could write plus 0, but that wouldn't be simplest form. So it's just y equals negative 3x. Okay, and you could pick any value that you wanted for x. Like if I picked, well, what if x is 1, right? Well, what's negative 3 times 1? Negative 3. So that would give me a y of negative 3. Well, look right here. That would be this point, 1, negative 3. Okay, let's look at this one. Okay, so slope dude, he's going from left to right. He's starting over here on this point on the left and going to this point on the right. So he's going to be, is he rising and running or is he going down and running? He's going up 2 and over 1, 2, 3, 4, 5. So y equals up 2 over 5 for my slope. So 2/5 x. And then where is this one crossing the y-axis? Crosses, remember this is the y-axis, it's crossing at 0, right? So I'm not going to write plus 0 because I don't have to do that. Okay, and then on your homework, they're going to look a little bit more like this where they don't have dots on them. That's just because the program that I'm having to use doesn't create dots. So you're going to kind of have to look and say, okay, well, there's a dot, like where is it crossing? There's a dot, okay, that kind of thing. So if I'm looking at this equation, y equals, going from left to right, slope dude is going up 1, 2, 3 and over 1, 2, 3, 4. So 3/4 x. And then where is this crossing the y-axis? It's crossing at negative 1, negative 2, negative 3. So minus 3. Okay, and this is pretty much the opposite of the homework that you practiced yesterday, right? Yesterday, I would have given you this equation, y equals 3/4 x minus 3. You would have said, oh, the y-intercept is negative 3, so I'm going to start there, and then I'm going to follow my slope and rise 3, run 4, and then connect them. So it's the same thing, but in reverse. Okay, and then this last one. And if you want to, go ahead and pause and try to figure it out on your own and then come back and check. Okay, but I will show you when you're done. Okay, so on this one, I know I can tell that it's crossing at this point and this point right here. So my equation, y equals, slope dude, is he going up and to the right or down and to the right? He's going down, so it's going to be negative slope. And he's going down 1, 2, 3, 4, 5 over 1, 2, 3, 4. So negative 5 over 4x. And then what's the y-intercept? It's crossing the y-axis on 5. So that's my answer, right? It's the opposite of what we practiced yesterday, where you would start on the y-intercept. Oh, well, that's positive 5, and then follow the slope, down 5 over 4.